Today we are going to be discussing TINTO and POCI, which stands for 2 or 3-dimensional imaging for NMR strip operation via computer vision. Specifically in this video, we are going to be discussing the 3D strip plot version protocol. So to begin, you need to have your acquired 3D spectra along with NHSQC and of course POCI. To start, we are going to identify and pick all peaks in the 15 NHSQC spectra. To do so, we are going to use this pointer mode and we are going to drag and select in the box all of our peaks in NHSQC. Today, I am using simulated ubiquitin, a dataset which already has peaks selected and assignments, but to show you how to do it, we did it anyway. From here, after all of your peaks are selected in your NHSQC spectra, we are going to open the strip plot using the 2-letter code SP. Once your strip plot window is open, we're going to go to Show and to CV Settings to ensure that our default settings are correct. Specifically, the masking option should be -1 for this method. Going to Apply, Close. Again, we are going to select the show and then select strip spectra. From here, we are going to select CBCNOH and HNCACB in this order as the strips are going to be added sequentially. Apply, close. From here, we are going to choose a peak in the 15 NHSQC spectra that corresponds to the amino acid I. I'm going to choose this one, add peak. I like to make these as skinny as possible because the next step is to Control A or Command A all of the peaks in your NHSQC spectra after this window is selected, and again add peak. As you can see, all of the strips from our spectra were added with our desired amino acid I, in this case V17, is at the forefront. The next step is to set up the size of the strips, trying to leave only the desired peaks in the view. This step is very important in order to have more accurate results. So to begin, I'm going to show you how to optimize this result and how to walk through the rest of the SSIM protocol, and then I will show you again the results without optimization. So to optimize, it is important to make them so that excess spectra are not being read within the algorithm. So to do this, we're going to zoom in on our peaks until there is no excess spectra and only the peaks that we want are shown. As you can see in these two strip windows, we have optimized our CBCNOH and HNCACB of our amino acid I to the best of our ability. From here, within the strip plot window, we are going to select the HNCACB strip from the amino acid I, which again in this case is 17. And we are going to press the SSIM or PCA button and wait for the results to be generated. In this video, I'm going to be pressing the SSIM button. As you can see, with optimization, the first result that SSIM produced for this amino acid was 18, which is the following amino acid. If you did not have assignments, as you probably would not, you would need to validate manually which strip corresponds to your desired amino acid. When looking for the I+1 amino acid, the carbon alpha and beta peaks that correspond to the amino acid I in the HNCACB spectrum should match the peaks in the CBCNOH spectrum from your I+1 chemical shift. The I CBCNOH shows you the I-1 residue of your HNCACB. So these that match are not your I. The I residues are the ones that do not match your CBCNOH from your I residue. And these carbon alphas and carbon betas are what need to match the CBCNOH of your I+1. And as you can see, these are perfect matches. Let me show you what it looks like when we do not optimize this window. So I'm going to delete all. I'm going back to my NHSQC. I'm going to type the 2-letter code LT. which provides me the assignment list of the data set, and I'm going to select the same peak, V17. I'm going to add this peak again. I'm going to go back to my NHSQC, select the window, select Control or Command A, and add all of those peaks back to my strip plot. From here, I am not going to do any optimization. I'm going to leave it like this. Going to select HNCACB and then select the SSIM button. Wait for the results to be generated. And again, the possible matching strips for CBC and OH of your I+1 will be displayed next to the HNCACB as a CBC and OH test. We're going to validate manually which strip corresponds to my desired amino acid. As you can see by the assignments already laid out, we are looking for amino acid 18, which is the I+1 of our amino acid 17. And within the top 10 ranks that SSIM provides, the I+1 amino acid 18 is not produced. This illustrates that the optimization of your strip window is very significant for your results. Thank you.